In the last video, guys, we saw how you can run different security audits using attack probes from Garak, and we saw how you can assess vulnerabilities on LLMs using Garak. For this video, I'm going to show you guys how you can run structured prompt injection attacks using a tool called Spikee, and this is the public repository of Spikee. Spikee was designed by Reversec Labs. And how Spikee works is it will generate a large structured dataset that will include 742 payloads, and it will run these payloads against a target model using a custom adapter, then provide a success breakdown of each attack category based on the attacks we carry out. So this is the public GitHub repository for Spikee. And prompt injection is ranked as first in OWASP top 10 LLM vulnerabilities, in this case, when assessing AI for security. So we're going to run these prompt injection attacks against our local model, which is Dolphin. We're going to use the same model that we used before, and you're going to target the chat endpoint completions. So we'll make sure to specify our public IP address for the model, and the model that we're using is Dolphin 3.0, designed by Cognitive Computations. So initially, we're going to start by assessing and verifying our connection to the model from our attacker virtual machine. And the attacker virtual machine, remember guys, is going to run Spikee locally and test our local LLM model. So we're going to send a call HTTP request to our LM Studio chat completions endpoint. Remember, it's using REST API. So we're going to see if you're going to get anything from that. Then you're going to declare the body format as a JSON body format. Then you're going to specify authorization as a bearer API token, assuming the API token from the local LLM is exposed. Then you're going to specify the API token. We're going to specify the name of the model, which is Dolphin. And we're going to specify the message type, which is hi. And as you can see, we're getting a response from the model. So just a correction, the model is supposed to be 3.0, not 2.6, but we still got a connection from our model. So make a note of that. When you're testing your connection, it's supposed to be Dolphin 3.0 and not 2.6. So we're going to switch back to our fuzzing AI tools directory, and we're going to create a new directory called Spikee Workspace. And we're going to cd and navigate to our Spikee workspace so that you can install Spikee. So once we create a directory, we'll begin by creating a virtual environment. So this is useful in creating an isolated Python environment where we can run most of our attacks from. Then we're going to activate a virtual environment. So right now we have a virtual environment activated inside our Spikee workspace. So we'll proceed to install Spikee using the official install commands from the GitHub repository. So we'll start by upgrading pip using pip install upgrade. Then we'll use pip installer to install Spikee. So we'll give it some time to run and install Spikee. Then we proceed to initialize the workspace using spike init command. And what it will do is it will create datasets, a targets, and a results folder directory, which is a structured format that Spikee uses when running the prompt injection attacks from the datasets that include the payloads. So Spikee, then initialize. Remember to do this after you install Spikee using pip command. And we can see different folder directories that are created. We have the attacks directory, we have the datasets directory, we have the plugins, we have the targets. In our case, what we want to do is we want to use our structured datasets from the datasets directory. So what we'll do is we'll verify the seed folders that are within the datasets directory, and we'll use a specific dataset called seeds, Cybersec 2026, which is the latest dataset of prompt injection attacks. So you can see seeds Cybersec 2026-01, and this is the seed folder that you're going to use to run our attacks. So once we verify the datasets that we're going to use, the next thing that we're going to do is we're going to create a target file, which will be basically a Python file that will translate the spikes internal format structure when trying to communicate with our API. And in this target file, we specify the default URL for our API endpoint, specify the key, and other details that we're going to use to test the communication between Spikee and our local LLM. So what it does is it will use the default URL, which is a chat's completion endpoint. It's going to use our API key, the one that is exposed. Again, remember to change the model name from 2.6 to 3.0, but it still worked in this case. So Dolphin 3.0. Then you're going to create a class called guardrail trigger that is going to create a custom exception of Spikee when the model refuses a request from HTTP. Remember, guys, HTTP is the endpoint that we're using for our communication with the LLM. Then we have a defined process input that is going to create a function that is going to create different payload tests. And these payload tests are going to be classed in terms of failure and success rates, depending on what we're going to get in terms of results. Remember, the content type is a JSON format. We already specified authorization to use the barrier API key token from our exposed LLM. Then you can see the messages to append. So we have the role, the user, and the content. So we are going to specify a message array conditionally that is going to add different system messages if one is provided. You're going to set the maximum allowed number of tokens to 512. Then in the response, you're going to specify none, which is going to initialize the response variable before any try is blocked, so that each exception handler can safely check if the request was never connected. So a way of verifying some of the requests, then we're going to build the messages and add a system message once it's provided. So let's run a test. And you can see we can communicate with our model, and it runs the target file, which has our API endpoint set up for a local LLM. And this confirms that Spikee can actually connect to our local LLM. And you can see from our devlogs section, we have details about the message that was sent. So this confirms Spikee can communicate with our LLM. So once that is confirmed, what you're going to do next is you're going to clear the Python cache and remove any compiled Python cache from the targets folder. Remember, we've already run an initial tests. So we're going to make sure that Spikee can load the old version of the targets file. And again, you're going to specify the seed folder, which is cybersec 2026-01, as our cluster dataset for running the Spikee commands. So we'll start by generating the datasets first in the seed folder that we're going to use. And you can see we have a JSON-L dataset file that has different jailbreak attack types. So these are all the payloads that we have in the dataset, each grouped by the attack type for the jailbreak. So you have no limits, you have dev, no different attacks. You can see each instruction. So you have data exfiltration if you want to exfiltrate any data from the LLM, XSS attacks. We have different languages that are going to be used. So it's not only limited to English, but you can also use different languages. And you're going to see how Spikee does that. So we've already generated our data set. It is included in the seed folder, cybersec 2026. The next thing you're going to do is you're going to confirm if that specific data set was created. So you're going to list all the data sets that are in JSON-L format, and you can see we have a data set created. Make sure to copy this specific data set, including all the numbers that you see at the end. And you're going to run the specific prompt injection tests that are coming from that data set and see the results that we're going to get. So Spikee, we are going to run an initial test command, and we set the sample rate to 5%. So we're going to reuse only 5% of the data set. The dash dash data set will specify our data set file. We are going to specify the target LM Studio Python 5 we created before. We're going to set the throttle to 1 so we can have 1 second wait in between each request so that we cannot overwhelm our local LLM. So it depends with your system resources. You can decide to use different throttles. So we're going to start this attack against our target model. Remember to change it to 3.0. And you can see Spikee is already running tests using different prompt injection attacks in the data set we provided. So we have our first category, which was the data exfiltration, and it's going to extract instructions that are hidden from inside the user input when the user queries the LLM. and we're going to see what output information we're going to get. It's also going to perform a context manipulation so that it can also try and alter the model's internal understanding and make it execute commands that are outside the security guardrails. Then it's going to run an instruction override, let's say for different security protocols. It's going to run an override and try and see if it can make the model perform instructions that are outside its boundary. And we're going to see all these once we generate a report. So the initial attack for the test is complete. And what we'll do is we're going to list the files that are in the results directory. And we're going to start by analyzing this first report that was created from Spikee. So the command that we're going to use to list the files in the results folder is ls, then -lt, then we're going to specify the results folder. And what we're going to use is the initial sample report that was created by Spikee. And this report basically prints the success rate breakdown of different payload samples that were used. And since we use only 5%, that's going to be around 37 payloads. And we'll see what results we get. So we have a breakdown by languages. You can see different languages and the success rate. We can see English had the highest success rate. We have different jailbreak types that were used. We can see the jailbreak type that is purposefully using prompts that include a mission biased uh, prompt having the highest success rate. We have errors, we have academic, we have dev, we have different instruction types, XSS, data exfiltration, long output, a breakdown by different tasks. You can see document has a success rate of 32. You can see by position if it's fixed. So a fixed position response gives the highest success rate. No plugins, remember, were used. You only use our dataset. Then you have a classification of the jailbreak type, different instruction types, the language used, and the success rate. So the highest one we can see is a test jailbreak type using an XSS instruction. And you can use this information to further escalate your attacks. But basically, you can see how Spikee works by running the datasets against the model, then giving you a breakdown. And you can use this information to further run different attacks and escalate your privileges. So the final thing to do is run the dataset, but this time we're going to run the full dataset for 742 payloads. Unlike the first attack, we're still going to set the throttle to 1 second. For the target tag, we're going to use Dolphin 26. So this tag will be the tag for the report. Remember, initially dash dash dataset specifies the name of the dataset you're going to use. Target specifies the LM Studio Python file we created, and we'll start our task. So this is going to take some time before it completes. So we'll give it some time. So just to confirm, we're going to check what's happening on LM Studio, and you can see all the payloads being tested and the responses coming from our model. And Spikee is running different attack categories. The prompt injection attacks from the dataset of the 742 payloads. It's performing exfiltration, instruction override, jailbreak chaining. Jailbreak chaining means basically using different jailbreak types like we saw on the success breakdown and chaining them to different data exfiltration techniques used and the instruction override used. So this, as you can see guys, is a bit different from what we did in in Garak, because in Garak we only assess the vulnerabilities, but this one is actually running the prompt injection attacks and giving you a breakdown of each attack and the jailbreak type that is used. So once it's done, we're going to analyze the success rate and see how it performed. And guys, you can be also creative and try and use this against different models. So if, for example, you want to run it against a different uncensored model like White Rabbit Neo, then you can find it from Hugging Face. Just simply download the model locally, like I showed you guys before on LM Studio, and you can pretty much test this against that specific model, then compare your results. So just like before, we are going to run an analysis using Spikee, and we're going to analyze the new report. So you can see we have 274 successful hits, and all the data was inserted in our JSON-L report. And we're going to analyze this using Spikee and see the results that we got. So similar to what we did with the initial target report for the sample reports, we're going to use Spikee. Then we're going to specify the results name, analyze, then we're going to specify the name of the results file. So we can see a breakdown of all the success rates of our attack. You can see the jailbreak types used and the success rate. So this one, we're getting 50% success rates using the different jailbreak types, and you can see the number of successful attacks was pretty much very high. 274 payloads worked using different jailbreak chaining types. And you can see we have done poetry, emergency, academic, errors, dev, mission. So different jailbreak types, each trying to manipulate our LLM. Then we have different instruction types. We can see that XSS is actually having a very high score for the instructions type. Then the task type, you can see it's a document. The success rate is 36. The positions that we saw initially. So this one, it's more so almost the same for the end and fixed positions. The number of injected payloads, you can see 742, and the success rates. And the different languages that were used by our model. And this gives the combination of the jailbreak types, instruction types, language use. So mission, we can see it's performing very well in terms of the prompt injection techniques used. And I think we can use this as a leverage in trying to perform other prompt injection attacks and different attacks on our LLM. So that was a complete prompt injection assessment using Spikee against a Dolphin model. And you can see the differences from Garak, where from Garak we saw a vulnerability scan using 9 attack probes. You can see that Spikee delved deeper and looked into multiple prompt injection techniques, and each are chained using different combinations of languages and jailbreak types. So that's it for this video. Make sure to drop a comment and like this video, share and subscribe. And see you guys in the next one.